Greetings, children. Today we will start light for class 7. Do you know light travels in a straight line? Well, you could try something. Take a torch and shine the torch on a dark night, and you will see that the beam of light produced by the torch travels into darkness because light travels in a straight line. Can you see in this picture the headlights of cars and scooters and buses? Don't you think they all travel in a straight line? But of course, they travel in a straight line in the darkness of the night. Isn't it beautiful? And this shows that light travels in a straight line. Can you see in this picture the straight beams of light coming out of the searchlights of airport towers? This also tells us that light travels in a straight line. You guessed it right. Light always travels in a straight line. When the air in a room is dusty, like in this picture, we can see a straight beam of sunlight entering the room through the windows or any opening or any hole that is open from where sunlight can enter the room. And can you see here? The beams of light are traveling in a straight line. A lot of the times, children come and ask me, if water can travel through a bent tube, why doesn't light travel through a bent tube? But light cannot travel through a bent tube. You know why? It's simple. Light travels in a straight line. So now we conclude that light always, always, always travels in a straight line. Now let's start with a new topic, reflection. Have you seen when light falls on the surface of an object, the object sends the light back. The process of sending back the rays of light that fall on the surface of that object is known as reflection of light. The rays of the sun's light that falls on the object or that directly come from some source, here we mention the sun. During the night, you see it coming from a bulb or a light tube. All these lights which directly come from the source, that is the sun or the bulb or the tube, are known as incident ray. In the diagram here, we can see that this ray of light is coming from a torch. Hence, the ray of light coming from a torch is known as the incident ray, and the torch is known as the source of light. Incident ray always comes from the source of light. Now, when this incident ray hits the surface of the object, can you see the surface of the object is sending back this light? The ray of light which is sent back by the object is known as the reflected ray. In this diagram, you can see the light is being reflected from a plane mirror, the kind of mirror that you see in your homes. In this figure, can you see the rays in blue? They are 6 in number. And they are all parallel to each other, which means they are all running together like the tracks of a train. So they are parallel and they hit the plane mirror. And can you see that all these incident rays are being reflected? They're being sent back. One important thing to remember here is that the angle of incidence is always equal to the angle of reflection. What do you think? Can only mirrors reflect light? Can you see here that light is being sent back or it is bouncing off this water body? In fact, any surface which is smooth and shiny, like glass, water, or polished metals, reflect light. Now let's come to a polished or an unpolished surface. The objects having polished, shiny surfaces, like we saw the water body in the previous clip, reflect more light than objects having rough and unpolished, dull surfaces, like in figure A. Now let's come to a polished or an unpolished surface. The objects having polished, shiny surfaces, like we saw the water body in the previous clip, reflect more light than objects having rough and unpolished, dull surfaces, like in figure A. When we take two different surfaces, say a smooth mirror and a rough surface, the mirror reflects all parts of the light and reflects it back. It throws it back, sends it back in the same angle as the angle of incidence. The mirror does not absorb any of the light. This is specular reflection. On a rough surface, however, all of the light is not reflected back because some of it is absorbed by the rough surface itself. This results in a diffused reflection.